this lecture, we will see how to draw the layout of a 2:1 mux from its twisted schematic using commands and magic. So, in order to open the terminal window, press Ctrl, Alt and T, then type magic and press enter. Now wait for the two windows to open. Now this is the layout window and this is the tick icon window. So in order to grid in, type grid. Now to zoom, press Z. Now since we need 3 PMOS and 3 NMOS, so we have to draw a bigger length anvil. So select a larger area and type paint anvil. Now the anvil of the two PMOS can be common, but we have to place separate P substrate. The P diffusion layer, so select, since we have to place 3, so select the area, then type paint pdiff. Similarly over here, paint pdiff. Now before that we have to extend this. Paint anvil. Now of the same area, first select from here, of the same area we have to place the third P diffusion. So paint pdiff. Okay, now just for uniformity, we can remove this extra layer. So select the area and type erase. Now this is the PMOS layer. Now similarly we have to draw the N MOSFETs. Select the area. There are 3 N MOSFET. So this is one. Then type paint N diffusion. This is one N diffusion. This is the second N diffusion. Now select the third N MOSFET region and type paint N diff. Now these are the 3 PMOS and these are the 3 NMOS. Now we know this is one transmission gate consisting of 1 PMOS NMOS. This is the second transmission gate NMOS and PMOS. This is the inverter. We are designing a 2:1 mux using 2 transmission gates and 1 inverter. So if I want to design a transmission gate, I have to short the sources and the drains with the help of metal layer. So select the area, and type paint M1. This was the shorting between the two sources. This is the shorting between the two drains. Then paint M1. So this is one transmission gate. Similarly over here, paint M1. Paint M1. Okay. Now after finishing the transmission gate, this is the source, this is the source, this is the drain, this is the drain terminal. Now let us finish first the transmission gate part. Now the transmission gate inputs are given by the inputs are given from the sources and outputs are obtained from the output is obtained from the drain. So over here the two drains are shorted. So zoom in. Paint M1. Similarly over here, paint M1. Paint M1. Now the drains are shorted. Okay. Now place the contacts. After this, after place the contacts, so select the area and type paint P diffusion contact. Paint PDC. Similarly over here, paint PDC. And for the end diffusion layer, paint NDC. We need this contact so that the metal layer is connected with this end diffusion layer. For the P diffusion we will use P diffusion contact, and for the N diffusion we will use the N diffusion contact. Okay, now for my convenience I will label this as input selector area and right click on the left bottom. So I get this dot, label, label, this is A, so A, or I'll type as VA, and this is, if I zoom in I can say this is VA. This is the output of this transmission gate and this is the input of the second transmission gate. Now label VB. Okay. Now the shorting of this drain terminal gives the output. So label Vout. Now next, before connecting the poly, we have to keep in mind that the poly of this PMOS is connected to the poly of the second NMOS, and the poly of the second PMOS is connected to the poly of the first NMOS. That is, the gate of the first PMOS is connected to the gate of the second NMOS, and the gate of the second PMOS is connected to the gate of the first NMOS. So we will select the area and paint poly. Similarly, place over here. Before that, paint poly. Paint poly. Now the gate connection is done from here to here. Now we have to connect this also. So what we will do, we can connect it from outside, not a problem. Paint poly. Paint poly. Now from here to here, paint poly. Okay, this should be connected over here. So undo. Next, paint poly. Now we have to connect from here to here. Okay, Shift Z. So this is connected, this gate is connected. Okay, now we have to design the inverter part. So the inverter is needed just for the selection line because we need S and S bar. So that's the reason why we need a inverter. So first design the gate, draw the gate layout, paint poly. After painting poly, next we have to design the gate. We have to design the source. Okay, so paint M1. This is a source of the same area. We will draw the drain, paint M1. After source and paint, after the source and the source, this is the source of the PMOS and this is the source of the NMOS, and this is the drain. The source of PMOS is connected to VDD and the source of NMOS is connected to ground. Now paint M1. Okay, now zoom in, select the area, paint P diffusion contact, paint P diffusion contact, paint N diffusion contact. Okay, now extend this ground, paint M1, paint M1. Okay, now this is Viridian ground. So we will label the Viridian ground. Okay, before that we have to place some contacts. So type paint. This is the N substrate contact or the N well contact. So NWC, and over here it's the P substrate contact or the P well contact. We can place as many as we want. Okay, now this is the select. So label S, or I can type VS, and this is the select bar. So VSB. This is the VDD. So label VDD. This is the ground. So label ground. Okay. Now after labeling the VDD and ground, so after giving the labels, is the select line, this is the select bar. After this, we have to connect the select and the select bar. So the select can be directly connected from here. From here to here. Paint M1. That should be P poly. So undo, paint poly. Okay. Now after connecting this, the select bar is connected with this. So we can connect from here. Paint poly. Okay, instead of drawing, we can directly erase. Try to directly connect from here. So paint M1. Paint M1. Paint M1. Just reduce the width. Connect from here to here. Paint poly. We can even increase from here to here. The metal layer can also be increased to match the width of the poly. So type paint M1. So you can see this select bar is connected with this gate. So we have to use a poly contact since the poly layer is overlapped with the metal layer. So select the area and then type paint poly contact. So type paint poly. Paint poly contact. Okay. So now all the labelings are done and the contacts are already placed. Now type say this is 2:1 mux. So mux 2, then find DRC find. So there are no DRC errors. Then extract ext. So extraction mux 2 into mux 2 underscore ext. The extracting file is done. Now we have to extract to sim file. so that we can simulate in IR sim. So ext to sim finished. Now in order to open the IR sim, we have to type IR sim mux2 dot sim. Now W, VA, VB and V out, and we have VS also. So W stands for watch. Watch the inputs and the output. D, display. So all the values are X. Now assign low to, let's say, VA and VS, and high to VB. Then S. So you can see VA is 0, VB is 1, select line is 0. So when select line is 0, then whatever the value of VB can be seen in the Vout. If I change the value of VB to 0, low VB, and then S, so Vout is 0. Now since my select was 0, low select, I will give high to select and high to VB, and high to VA. Now S. So since my select is 1, then whatever the value of VA will be seen in Vout. If I give low value to VA, then you can see the output is 0. Even if I change the value of VB, that won't affect my output. The output will be 0. If I want to see this in the analyzer, then type ANA, VA, VB, VS and Vout. Zoom to full. Now this is when select line is 0, whatever the value of VB you can see in the output. VB value is 1. Now again the select line is 0, VB is 0, so output is 0. Now here VS is 1. Now when VS is 1, whatever the value of VA will be seen in the output. From here it's 1. Sorry, from here it's 1. So the output is 1. Here it's 0. So the output is 0. Same over here. So this is how a 2:1 mux functions, and this is how the 2:1 mux is designed using two transmission gates. This is the layout of a 2:1 mux. Let's draw the layout of a 2:1 mux using the transmission gates by using the toolbar in Magic. First, open the terminal window by pressing Ctrl Alt and T. Then type Magic. So this is the layout window. Now we will use the toolbar. So go to options and select toolbar. So you can see the layers present over here, the NVEL layer, then poly, P diffusion, contact, etc. So in order to grid in, press G in keyboard. Now in order to zoom in, press Z. In order to zoom out, press Shift Z. Now since we need 3 PMOS, so we have to select a larger area of NVEL. So select the area, then middle click on NVEL. Now this is the area for NVEL. Now draw the P diffusion layer. So there will be 3 P diffusion for 3 PMOS. So select the area. So this is 1 PMOS. After selecting the area, middle click on the P diffusion layer. This is 1. Then the second P diffusion layer, middle click. Now this is insufficient, so we have to increase the NVEL layer. So select the area and then middle click on NVEL. Okay, now select this area of P diffusion because we need uniformity. Then middle click on P diffusion. After this, so this is the 3 PMOS. These are the 3 PMOS. Then similarly we have to draw the N diffusion layer. So this is the green, the N diffusion layer is green in color. So middle click the N diffusion. This is 1. Then similarly we need more 2. Middle click. Then the third one. In order to select any of the layer, we have to middle click. Now these 3 PMOS and 3 NMOS, they constitute 2 transmission gates and 1 inverter. So this is 1 transmission gate, this is the second transmission gate, and this is the inverter. Inverter is used in order to obtain the invert of select line. So in order to draw the transmission gate, first short the 2 sources and the 2 drains. So select the area, and then middle click on the metal layer, that is metal 1. This is how the 2 sources of transmission gate 1 are shorted. Now similarly over here these 2 drains are shorted between the NMOS and PMOS. Similarly in the second transmission gate, middle click on M1, over here middle click on M1, middle click on M1. So the 2 sources and the 2 drains are shorted. Now place the contacts zoom in. Since this is the P diffusion layer, so place the P diffusion contact, select. Okay, if we want, we can just increase this metal layer. So keep on middle clicking. This is so needed in order to obtain a proper square shape contact. Or you can directly place over here. Since this is a metal layer, I can middle click over here also. From here. Similarly over here. Now it's easy for us to create a square shape contact. Now select the area and then middle click on the P diffusion contact. This is one. This contact is needed in order to connect this P diffusion layer with this metal layer. Select the area, middle click on P diffusion contact, PD contact. After placing the P diffusion contact, place the N diffusion contact, that is NDC. So select the area, then middle click on ND contact. ND contact. Now, after shorting the sources and drains, this is the input, the two inputs of the mux are obtained from the source of transmission gate 1 and the source of transmission gate 2. So this is the input 1, this is the input 2. So first label these inputs, select the area and then right click on the bottom left of the selected area. So this dot point is obtained and then type label VA, or you can type label A. Similarly over here type label B, undo, because this is the drain terminal, this is the source terminal. So right click, type label VB. This is input A. Okay, again undo, label B. After labeling AB, the inputs, we have to label the output. There is also a third input, that is the select line, that we will draw in the inverter. So first join the two drains of the transmission gate, select the area, middle click on metal 1. Similarly over here, then from here to here. Okay, the drains are connected. Now select the area, right click and label it as out. Okay, now after drawing the sources and drains, we have to draw the gates. So the gate of the PMOS 1 of the transmission gate 1 is connected to the NMOS 2 of the transmission gate 2, and the PMOS of transmission gate 2 is connected to the NMOS of transmission gate 1. So select the area, then middle click on the poly layer. Similarly place this over here, then middle click on poly, middle click on poly. So here the two gates are connected. Now similarly connect the gate from here, select the area, then middle click on polysilicon, select the area, middle click on polysilicon, now from here to here. Okay, select the area, then middle click on poly. I can click from here also. Now we have to join these two gates. So select from here, then middle click on polysilicon. Okay, these two gates are shorted and these two gates are shorted. Now we have to design the select. So this is the inverter. So draw the gate first. Draw the gate first. Then middle click on polysilicon. Then from here middle click on M1. So this is the source of the PMOS. Similarly, this is the source of the NMOS. Middle click on M1. From here to here, middle click on M1. Okay. Now this is the source connected to VDD. So similarly over here we have to short the two drains. So select area, middle click on M2. M1. Middle click on M1. Now place the contacts here, the N substrate, the P substrate contact. So middle click P diffusion contact, middle click on PD contact. again the PD contact. Similarly over here the N diffusion contact or the ND contact, ND contact. Then here we have the N substrate contact, here the N substrate contact. Okay, now this is the inverter. We have to label the VDD and ground. So select the area and type label VDD. Similarly label ground. After labeling the VDD and ground, this is the select line. So click over here and type label S, and this is the output of the inverter, that is the inverted form of S, that is S bar or SB. Now the select line is connected to this gate. So select the area and then middle click on polysilicon, and the S bar is connected to this gate. So select from here, then we'll click on M1, middle click on M1. Now connect from here to here, and middle click on polysilicon. Okay, now since this polysilicon and metal are connected, since this polysilicon and metal are connected, select the area and then place a contact. So we'll place a contact from here. This is the poly contact, middle click on poly contact. So now this is also connected. We have labeled all the inputs and outputs. Now say mux 3, then find the DRC errors. DRC find, there are no errors in mux 3. Then extract ext. Now extract to sim, since the sim file is needed to simulate in IRSIM. Then press enter. Sim file is extracted. Now type IRSIM mux3.sim. Then type W stands for watch, Watch A, B, S. Okay. Since S is also a command, so remove it and label it as label VS. Now save. Now type ext to sim, then irsim, mux3 dot sim, then w a b vs and out, then type d. So you can see out vs a and b values are x. Now type L stands for low value. Give low value to B, LB and VS, the select line. Press enter and press S. So since we have not given any value to A, it's showing X, and since the select line is 0, whatever the value of B will be there is seen in the output. Let's give high value to low value to A, then S. Now how high value to B and S. Now high value to A, when A is 1, output is 1. Let's give low value to high value to VS. Now S. So whatever the value of B can be seen in the output. LB. If I want to analyze, then ANA, ANA, A, B, VS and out. This was the earlier portion. Now you can see when VS is 0, output is 1. When VS is 1, output is 1. When VS is 1, then whatever is there in A is seen in the output, and when VS is 0, whatever is there in B is seen in output. So if I give LB, now exit.